Okay. Do this. Do that. So for your next exam, you should expect another transmission line question. This time you'll be trying to find more related towards stub matching. And then the second question will probably be from chapter 6, something similar to this. Now, I don't know if he's going to ask something about chapter 7, but you have done something like this already on the homeworks. We'll just go over it a little bit just in case he decides to put that on the exam. And then I know that y'all have already done the stub matching lab, so we'll go from there. Now I need a pen. Okay. Okay, so we'll start with what question? There we go. Okay. So we know that Z naught, the length isn't in wavelengths, but we're given what the wavelength is. And then we're given what S11 is, which is right here. So for part A, we're asked to find the load that is on the impedance, so ZA. So for that, we're going to be using S11. Do we know what S11 is? Labs, question mark. Do we know what S11 is? It's the reflection. Okay. So we can say that it's something similar to gamma. And we know that gamma is equal to an impedance. We'll get to that in a minute. Minus the Z naught, plus Z naught. Look at this. Here's my exam. Here's my own exam. Getting things. Okay. So for gamma, the equation normally is ZL minus Z naught over ZL plus the Z naught. But if we know if S11 is the reflection coefficient, then here, what this diagram is stating is that the reflection coefficient at the beginning of the transmission line is going to be this value. So with that in mind, can we say that this impedance is ZL? No, why can it not be ZL? What else do we need to include? Yeah, because we need to include the transmission line itself when setting the S11 equal to gamma. And so with this, we know what S11 is. We don't know what Zn is, but we know what Z naught is. So we'll just modify our equation for Zn into this equation into something for Zn. So with that, you can either do it on the calculator, doing solve, or you do it brute force way. I think I have it. Don't have it. But after some manipulation, we get that Zn is equal to Z naught S11 plus 1 over 1 minus S11. Okay. So from there, we would be able to get a value for Zn. One step closer. So from here, we know that if we shift Za through the transmission line, we can get Zn. So for Zn, we know that Zn is equal to Z naught So we know this, just a simple Zn equation. From here, we know Zn because we found it above. We know Z naught. Za is the unknown. Z naught we know. Beta we can find because we're given wavelengths. And then the length we know it as well. So let's solve for beta L. So we know that beta, what's beta equal to? We know it's 2 pi over lambda. And then the length is just length. We know lambda, we know length. So that's known. From here, you can either do solve, or you can do the math for it. So, for here, now if we make a simplification where we define Zn, small Zn is equal to Zn over Z naught, then we get here, we distribute over, but we must keep in mind that we're using this Zn at the moment. We would distribute over the denominator to the left side. We would get this. From here, we would collect terms. So we would collect the Za on the left and the Z naught on the right. And then from here, just simple division to get what Za would be. Zn, tiny Zn. We did it. You want answers? We will see if we get answers with time. Yeah. So, let me write it down. So there's part A. That was part A. From here, we get to single stub matching, the important part. So we know that single stub matching is used on the 50 transmission line. We're trying to find the closest distance, dm, of the length corresponding to a short stub. So we want a short stub length of this. With this, I'll be very careful, especially after seeing how y'all solved your homework. One question on your homework. If you got that one right, continue doing that. But if you didn't, please pay attention. Especially some of the people almost got it right, but they had a negative value for the length. So what does that mean? That means that the length would be over here. We would be putting something on this side if we get a negative length. That's not possible. So we need to bring it into the positive. And so with that, if you saw in your homework, I put, you would add lambda half. That's also in the book, just a trick to make that negative length into a positive length. I'm going to write those equations on here in case you didn't get them in your lab. Okay. So I got this right. Okay. I'm gonna put it like this on your lab. So throughout these equations, you'll see a plus or minus. You will need the plus or minus.
Do you want to make note of that tau was for the load?
That one?
Yeah, it should be right.
Yeah.
It's not the beginning.
No. That one is just.
Would be ZA minus.
I'm gonna do this. Okay. Different gammas. This one's for the actual impedance line from the load. Okay. From there, we get stub. Hold on. Plus or minus? Francis. Is that plus or minus? Right? Okay. Because I have two different ones. The picture has minus, but then the ones I use.
Shouldn't you do both? You should do the plus version and the minus version, and then and then see whichever one's shorter.
I'm just writing down the equation. Oh, it kind of doesn't matter. It don't matter. Yeah, it don't matter. It doesn't matter. It doesn't matter because this is gonna be plus or minus, so it don't matter.
Oh, that's right.
That it don't matter. It won't matter. We can say you end up with two values here, and then here you end up with two values here. This one, forgot to mention, will be the angle of your gamma. So yeah, it's just the phase. Just the phase of this over here. Same with this is just the magnitude. Because whenever you get this, you'll get with the magnitude E J phase. So just, from here, please take note, I took note as well, that when you evaluate the distance of the stub, you need to take the smallest one, the shorter value, and also the positive one. Like, let's say we end up with something like, just an example. So let's say we end up with okay, both negatives. So first thing we're going to do, we'll bring them positive. So we'll add the half lambda divided by 2. Then we'll get a positive value for both of them. And then from here, we'll take the shortest one. Oh, sorry. So, just an example. So let's say if we end up with like something like this, then we'll take smaller one. Make sure they're positive, by the way. So. No. Okay. And then from here, we can find the impedance, like at the end of the stub. So for that, we can say it's, oh my God, hold up. Oh, let's get this step. Make this a B. BS. We'll do, this is 2. That. Forgetting what I had. Okay. Yes. Now we can do the ZS. It's BS. JBS. And then we finally get to the length.
Can you move it?
Okay. With this one, we'll make the same note as well. We'll make them positive. And then we'll take the shortest distance. Almost done. Yeah. Don't want to write it again. Same thing as before. One more thing to keep in mind is all of these have had 2 answers. And you need to keep in mind that you need to keep using the same one. Make sure. Yes.
So for the ones that you need to take that consideration about positive adding choice, and a positive value or answer and a negative answer, do you automatically
You still have to add the other one
to save it?
because maybe it's shorter.
Okay.
Yeah. Yeah, because that's the thing is you always want to take the shorter distance for it. And that's what's asking on the question. It says find the closest position, meaning the shortest position, the shortest length into it.
The two values for BS, is that just because you have two values in these?
Yes. Yes, and then from there, that's, so for the D stub, you would keep in mind here, and then from there, you wouldn't need these. So from here, whichever, start here.
Yeah, it's BS.
BS, yeah.
Whichever theta gives you the least distance, that's the theta prime that you use. You don't have to use two.
That's what I'm trying to see.
It should work for just the D-stub shortest distance theta.
Let me see. Let's see. So we have that. And then we got, what did we get for tau? What did we get for tau? Let me see, where's ZA? Oh, I got the wrong value for ZA. We'll go with that. Let's see, what did Obit choose? Okay. So D stub 0.13, that I chose that one. And then from there BS 133, ZS 37, 48. Oh, that's right. LS 0.1, 0.1. Okay, so yeah, no, okay. So yeah, here you make considerations here, there, and then here as well. So you don't really, this is just to get your other two values. Because then you would still need to have the two L shorts. So that's where you're getting, you would need to continue having those two values as you move along to end up with two and possible answers for the lengths of the stubs. So you kind of just look based on here, and then at the end with the L's. But keep in mind, you're gonna need to plug in this one here to get your left one, and then from here you would plug it in here to get your left one, and then same with like that as well. For both of them.
So you still have to use both?
You still have
for
to
the
use
whole
both.
way?
So the whole way you have to use it. So you know, because there's two possible choices for the for this.
Oh, and then the shortest.
The shortest one, you would take that one. Mm-hmm. Yeah. It makes it easy if you're able to program your calculator.
So for each, the two D stubs will have an L short and an L.
Yes. Like something. Like this was my exam. Like as you see here, D stub, I have two possible choices. Don't copy these answers, they're wrong. And then you see how this one was negative, so I brought it into positive. But when you compare these two, that one's the shortest one for D stub. Then for BS, you end up with two answers. You go there to ZS, likewise two answers. And then when you start actually using them is over here with LS. So you see you end up with two answers. This one's negative, So I added it and I got 0.397, but this one was 0.1. So I used the shortest one.
So when it's a negative, you
Just add the 0.5. If you're keeping it in the wavelengths, just add the 0.5. If not, then you have to add the 0.5 times whatever your lambda is.
So did you use both these steps or just one?
Where?
Uh,
Here? Yeah, I used both of them. You see there's two answers. But then when I added this one's longer than this one.
So you took the short.
I took the shortest.
and do you ever use the longer one again for the problem, or it's gone?
No,
Okay.
it's just comparing.
So then you get two answers again from BS, or?
Yes, you end up with two answers for BS, which gives you two answers for ZS, which then gives you two answers for LS.
And what about BS gives you two answers?
The phase for right here, this angle. You end up with two angles, and you're using it here.
Okay, but one of those angles, doesn't it correspond to the D stub that you discarded?
That's where.
That's what I was saying before.
What do you think, Francis? Yeah.
So basically, the reason why we want to use and keep track of both betas is because we're trying to make a comparison amongst two different phases, basically. We don't know until the very end which distance is going to be better for us. Okay? For all we know, question could have been asking for both, question could have been asking for your short and your open stub, or just seeing, hey, which one's the shortest distance. You don't know that information until you go through this entire process. Though the equations themselves, they're pretty straightforward. There's no tricks behind it. There's no you change it up and stuff. It's just these equations, plug it in, see what happens. And then towards the very end, reason why we still keep track of it is because in this one we asked for specifically L short, but again, it may not be within the range of the problem saying is like, hey, this region is can't access it, or you notice it's in a negative value, meaning it's off the transmission line itself. You still go ahead and keep track of that, then compare it back over, and then you have your two values there: the distance from your load, and then the length of the actual stub itself.
So I would say just put both of them on the exam.
So don't worry about which D stub is shorter or longer.
Just put
Just
everything.
keep using both.
Just
all
put
the way to
everything
the
on it,
end.
and then just.
Okay, so just keep using both.
And then
all
just
the way
from
to the
it, just
end.
make your observation be like, oh, which one's shorter?
Once you get to that.
Yeah.
Just be like, this one's shorter. You call it a day, and then come on, let's move on to the next question.
What if we have two transition
As in like two loads on it, you would treat it normally how you would, but you would have to make it in a form that you're familiar with, as in maybe combining it into one load.
So yeah,
There's no way you could do
There's no way you would
it.
do
It
that.
would take way too long if you did it.
No.
If you did that.
There's no way.
There's no way.
I don't trust.
I don't trust him either, but he wouldn't do something like that. There'd be no time.
I was like, he knows something.
Because that single problem takes so long to do anyway.
yeah.
Bro, I wouldn't be surprised.
Yep. Yeah.
At this point.
And this is how don't break it, don't break it. Oh my
You
god.
just went up to your actual function class list. Okay, that's all you're doing.
Okay, don't.
There
Okay,
you
let's
go.
not break it.
You're fine, all right.
Okay, so this is how I program my character. I made the fonts very tiny.
Zoom in. You can hold it down. Don't forget.
I don't want to hold it down because then it just calls, just like.
Yeah.
There you go.
Very tiny. So that's Z naught. We define Z naught. Then we define ZL. This is gamma. We define gamma. We need to use the magnitude of gamma, so we define magnitude gamma. We find the angle for gamma. Here's theta prime. Theta prime. You see, I'm taking the positive and the negative right there, and that's where the whole two answers comes into play. D stub there. I made a little note though. So you gotta evaluate it, and then by taking the positive version and then the shorter version. BS, ZS, there's L short, and then L open. And this is all through notes, and then just math boxes. Yes.
So whether we ask for the length of a short or an open, the middle math doesn't change, right? Only the very
At the end. It's all at the end. Because here, the only thing that, what's it? Oh, right here. So you see the only thing that changes is when the ZS and Z naught get flipped for the short and the open.
But BS, ZS, and
That's all the same.
all same, right? Okay.
BS, ZS is the same. Same with the angle, angle prime. Yeah. That's how you solve the question. First question. Oh, we got over time. Next question should be something similar to this. Maybe he'll change up the shape. Probably won't be a circle, because there's been a circle twice already.
Hopefully it's not so weird.
It could be square.
It could probably be a square. So one thing for this I would say is freshen up on your taking double integrals for just shapes. So,
Star shape or a heart.
because you're gonna be doing it for VMF. So, okay, let's.
I'm assuming it's not gonna be. It's gonna be a square or maybe a circle, pot like or a rectangle.
Yeah.
Not something weird.
Yeah, because even the homework just had circles. So. Trying to pull up my little notes. Okay. Okay, so we're given a wire that has been turned 7, so it has 7 turns. So that's our n, with the radius of 0.5. So we know that's 0.5. It's in the xy plane, free space. We know that this is 100 that, and then this is 10 ohms. Okay. He was nice. He gave us an equation. The equation for we know that the flux is equal to that, and then the area. Pretty sure that's area. He gave us W. Okay. So for the first part, we're just trying to find VMF. Pretty simple. You've already done this on your homework. Pretty well. Hope you actually did it and not just copied, but if you copied, learned something. So, first part. Do you remember what the equation for VMF is? Just normal VMF. No transformer, no. Not that one.
Change of flux with respect to time.
Respect to it's over surface.
Well, I'm
Yeah.
just saying like the derivative.
Yeah. You take the derivative of the change of your flux. So it's going to be this. Okay. So for this, from here, we know that, I think that's this is another equation. This one. No, do we need anything? We do need the circle. Okay. We'll start here. Oh. Sorry, guys. I skipped a step. Skipped a very important step. Put this up here. Let's solve for this. Because we're going to need B. We'll need the flux. So let's solve for that. So the equation actually starts with solving for this. We first start with this. That's where the question actually starts. It gives points for just solving this. If it gives, if we're able to solve this, then it gets the points. Okay, so let's hope we know how to take cross product.
Isn't this like a 3x3 matrix thing? Yeah. Partial derivative is x, y, z, and then partial derivative with respect to x, partial derivative with respect to y. Which is
I
that
don't really
long
want to
answer.
write this. AX? I'll just write AX.
Yeah, that's a good.
Because I'm not writing all of that. Right there. I didn't put space for it. So yeah, so I hope you are able to do this pretty quickly. And I'm thinking he's only gonna give 2 questions because of this. Right? You think so? Because they barely started chapter 7. Well, obviously this and the sub.
Yeah. I believe it's going to be 3 questions.
3?
Yes. I just have.
You have a feeling?
I feel like.
We gotta hurry it up.
We talked about
It's okay,
that.
guys. I'm also recording on Teams, so if time runs out, it's still being recorded. Yeah, you get something. Well, I know the answer, so you should get something like. You should get that. Okay. That's the only value you're gonna get today. Sorry. Because it's gonna be theoretical. Just okay. We got B. Just plug it in here. Put this integral and this d of s. So that means we're taking the integral of the surface But D of S, there's a chart table in your book of all the D of S's you can use. So you could do D of X, dx, dy, dz, dr, d theta. Forgot what the other part was. Phi. Is it phi? The angle? No, that's theta.
Yeah, that's depends which coordinate system.
No, it's spherical. There's two angles.
Should just be R.
Oh, dx is just two. It's just dx, dy, or dr, d theta. Yeah. Okay. What do you want to do? Dx, dy, or dr, d theta? Don't be like me and chooses the wrong one on the test and forgets the equation. Huh? We'll do both then. Okay. So if we define d of s to be dx dy, so that means we're going to take the integral in terms of dx dy. And for this, one thing we need to know is the equation of a circle. What's the equation of a circle?
Pi r squared. Like the area.
Equation of a circle. Like if you want to plot a circle,
X
squared plus y squared.
Oh, yeah.
Equals some constant.
there we go. So we'll use that. Another form you can do, which is the easy way.
So depending on the shape,
Yes.
and they dr times the entire circle.
Yes. You will.
Di dy would be better for square.
Yes. Because it's just 5 for square. But this, it changes. The actual it's changing over time. So this one's gonna be easier if you use drd theta. For that, if we use drd theta, we will define it as the dot. If we define it using drd theta, we need to make it's gonna be this. It's gonna be that. So if we use that, then yes.
Isn't the z hat dependent upon the plane that he uses as well? He uses
Z
X
hat.
and Y plane, so that's why it's z hat, right?
Yeah.
So you could swap the plane to like zy or something, so then it fucks with your equations too.
Yeah. It's. Let me see if I can find it on the
I know
book.
he's done that before.
What chapter would it be? Chapter 3, I think. Where's the table? That one table?
Because it's not always z, and that's right.
Hold up. Exam. What?
Yeah, in the X and Y, right? So since it's on X, yes. But if he gets Z and Y, then it'll be the X plane. Yeah, that's what I was saying. It depends on the plane that he's using.
So this is the table.
Yeah.
'Cause
He's done.
See, it's in chapter 4 or 5, or 3, one of those.
It's table 3-4.
There you go. Chapter 3. It's in chapter 3. So from here we know it's ds, and this is where, yeah. So you would use the z because we're on the xy plane. Use the other one, right? Yeah. So it would be, oh, yeah. So I forgot something on here, so it's like that. And that's that because when we take the dot, it gets canceled out with it.
Yeah.
Okay.
Yeah.
So our integral will be and then with this, the way Twacha just said, would just plug it into your calculator, and you'll get a value.
Is there nothing before that double equation that gets it to there?
What do you mean?
Like, aren't you?
Yes, there's a dot.
Okay, yeah.
You're dotting it, so the y term like vanishes
Yeah.
because there's no y to multiply with, so it's just 0, so it falls off. But you still keep the z because there's the z.
And then the z and the z cancel, so they're in.
Well, yeah, because when you take the dot, you get a scalar, so no more. Boundaries?
What's the radius?
With the radius. So you take the first integrals with the radius, respect to radius. So it's 0 to 0.5. And then d theta is 0 to 2 pi.
This is where the shape part comes into play.
All the way
because
around.
that integral setup can change depending on the perimeter or whatever shape the loops are going.
Okay. Okay. From there,
And there's a table for that, right? You said, or no?
for what?
For like if it's a square or a triangle or something.
Yes. For what do you mean?
For the.
For
integrals.
these, for d of s's.
Oh, there's no table for the integrals if it's like a square or whatever. You just
That's why I
have
said you need to study up on your like double integrals.
Yeah. Oh.
Because then if you want to take a dx dy, then you have to do the whole this way. It's you find your bounds. So it's all depending on which way you want to make it. If you want to make your life easy, this is circular. But if you want to make your life hard, you could do dx dy and then just find how to parameterize the circle. Yeah. So it's all up to you. I would study upon trying to take integrals. Well, the more part on parameterization. Okay. From there, we would get a value for this. And so we would just plug it back in over here. So from there, we would take the derivative with respect to time, and then just multiply it by the turns. And it'll specify that it was a 7 turn. Yeah. So.
That was the question, right? Find me.
VMF.
there a second part to that or no?
Nope. Oh, well, there's more parts. So that was all part one. That was just part A of 3 parts. It gets easier. The parts are a little bit easier as you after this. The next part is find the time varying current, and then time varying power. Time average power.
Yeah, that's what it does say.
Okay. So if we use phasor form to find, let's first these, the R and C, we can define it as ZL equaling R plus that. And then from there, we continue in phasor, is just going to be one thing to keep in mind, our BMF, this BMF, different from this BMF. They're different. Why are they different?
That one is phasor and that one should be, oh wait, that one's time.
That one's time,
That one's phasor.
phasor. That's all it is. No, just make sure this is in time. That's the phasor one. So keep that in mind. And then you should just we'll end up with something like that. And then since it's asking for time varying, then we would just take the real part of our loop. And then we'll get something like oh, they're the same angle. Even though I use different oh my god. They're the same. There's B. Very simple. C, time average power. So we know that our time average power will be, and it's asking in specifically for the resistor.
So capacitor doesn't dissipate.
Don't forget the conjugate, please. Notice that in your homeworks. I forgot your conjugates. Oh, it's not getting great. This. What else can we define this as equal to? Because we don't know what VR is equal to, but V is equal to Ohm's law, IR. So we know that this is also equal to I loop times the R. This just simply the I loop with a conjugate. So after, bring it down. These two, do we know what those two are equal to? Do you know what that is equal to? Making the normal part and plus its times its conjugate. It's its magnitude. So we can say it's also equal to should still be the conjugate. Sorry, not the phasor. Yeah. That's question 2. Done. That's question 2. Do you want to go over this one? Chapter 7.
Might as well.
You would put a capacitor on here, you know, where it's split into 2 chunks. Is that?
That was
third?
chapter 4-5.
Okay, that's.
Yeah.
I think we did great.
No, yeah, that was chapter 4-5, so it won't get covered on this exam forever. I'm a bit iffy on if this is gonna get covered by how long it took us to do those two. Unless he doesn't include S11 in that first one and just tells you to find the stub, then he could probably include a third one.
You think
I don't
we
know.
give us voltages instead?
For
Like input voltage.
what he may do,
And then you have to find, you know,
what he may do is I'll give you that, and then just say this is equal to a value plus that.
We did that for last exam.
So you know you may expect that again because hope you know the equation for him.
Oh,
They were also in your homework. That specific question was in your homework, by the way. So bit shocking. Yes.
And you wouldn't give us a link.
you can calculate.
Yeah, you can calculate that.
You can calculate length too, I think.
Well, length would be given. Length was given last time, but it wasn't given in lambdas like here.
Yeah.
Here he gave you a lambda, so it's still, I don't know.
Even if it doesn't give you lambda, you can still use lambda as a variable, right? Just don't put in a value for it.
In terms of wavelengths and such, yes, that's a way to do it.
He-
But if he gives you the actual finite length values, expect to be
Yes, because for this, he'll give you points if you give your answer in wavelengths, but he'll give you the full points if you plug in the wavelength. So you may need to know what the wavelength was for that.
The equations you calculate the wavelength based on.
Do we know what they are? Those 3 equations that we probably didn't have on our cheat sheet last time. You know them? Anyone? Let's say we're given that. We want to find lambda. So we start with finding the UP. Which one? Let me see. That. And then from there we find lambda. We know the lambda is either, oh, that's just u. UP over frequency.
It's also
He would need to give you either the way the frequency or W. But this is also 2 pi. And then the equation y'all were all wanting was this one. Those are the ones you needed on your last exam.
you don't have the equation for lambda where it's lambda naught, right? You can look where it's lambda naught at the top divided by.
Oh, no. I don't
If I remember using, I used that one.
Hold on. This one was the one they were using on the homework. I remember this one was the one that was used. Nice. Okay.
Yeah, it's lambda naught. Something like this. Yeah, and lambda naught is its own fact too. I just remember it being, yeah, I just remember it being another equation.
So for this one, there's 2 equations. There's the one in chapter 7 to find the magnetic field in respect to the electric field. That one is only used for when it is a plane wave. That is the only one, the only criteria to use that equation, which was, let me see if I can find it. Where are you? Oh my God. These equations, only if it's a plane wave. And this is different from the ones that were used in chapter 6. Chapter 6 is just, I think you could use it just in general. That one's just the in general, but this one's only for plane waves. Duarte doesn't really like these. Doesn't really uses them. He uses the one in chapter 6, which is the one I'm going to write down. It's because you have to, if he doesn't like using them if you don't know how to characterize a plane wave. That's the only way. That's the only reason why. But as you should remember from your homework, we can find h of time harmonic. So dang it, that's not how I do it. It's like this. So it's bold because it's a vector, and then it's squiggly because it's a phasor, or in time harmonic. A few things I noticed in your homework. We can make the assumption that this is U0 because it's telling us this is in free space, but it's not this is just that. But this is equal to that. Don't forget that. Same with, the epsilon. A thing with this one was this was not given. So that is a question mark. So you need to, so from here, we can say this is equal to KC. What is our K? Our K will be this 200 pi. That's our K. So we know from the question our K is 200 pi. And I think, same thing. So know that. C is the speed of light. U naught, it's 4 pi times 10 to the negative 7. That, yeah. This one was a horrible cross product. It was very annoying. You end up with after doing the cross product, you end up with a very long equation. But then when you multiply with this, it all gets taken out. So it's very sad. So for that, we're going to need this in a different form from that. So we can say this. We got this. We would plug it into the cross product, similar to the one before. Simple cross product. You end up with an answer. Let's see, was mine right? I don't think it was. Wait, hold up. Yes, it was right. So after doing cross product, your H, you should end up with something like this. And that was part A. Now, some things you need to keep in mind to making this equation. This, we derive it from over here, from this J. This right here. Oh, sorry, that. We get it from the J, this negative J. Because we know that negative J is equal to e to the negative pi half j. We know that. So just, removing that j. Just some tricks. So that was our part A. Just this equation right here. And you could actually make that assumption from chapter 7 that this was a plane wave, because it was a plane wave. So you could have used the equation. But to be safe and sorry, you could always just use the one from chapter 6. From here, no, because it's time harmonic vector. Time harmonic vector. The bold is the line on the left. For B, where can we do this? Yeah, and this is why I'm like, I don't think it's going to be on the exam. Because they haven't covered polarization states.
It's either that or given its frequency, because that's another way.
How else could he ask this question? No, because in chapter 6, there was the other question, and then the other questions was finding the magnetic field. Wavelength? Oh. I don't think it's going to be on there. I think so.
Do we need the second part to do the third part? Right? The direction.
Yes. Do you find frequency? That. There's frequency. Polarization state. It hasn't been covered. And he hasn't assigned chapter 7. I don't remember. Twatch is scary. He started though, but I don't think.
If he covers it in lecture Tuesday, then that's the
Because polarization.
Polarization
States is at the very end of chapter 7.
Should we ask him, or he's not gonna?
He's not gonna tell us.
He's not gonna tell us.
Yeah. He loves to fuck with you.
It
We
might
always
be
ask
just
him, like, what he's saying, because if you ask him, like, since we have to cut the whole
I think he just barely got interested. Trying to email him.
We have. Yeah.
Is there any other questions from any previous exams that have been 3 questions that you remember?
The same.
I only remember 2.
The one from before, it was a square loop. No, that one has polarized. Yours had polarized. Because it said find the electric field intensity based on it being polarized in a certain direction.
Like a square or something. I know it's given a different English without using S. Is that K is equal to?
Yeah. I think that equation is in chapter 7 though.
Yeah, I'll throw it on there. You never know.
Yeah, that's in chapter 7. That equation is in chapter 7.
Wait, I think he just went over that.
Yeah.
I'm pretty sure that's where he got to.
Yeah, that's.
Yeah, that's exactly.
I could.
his endpoint,
I think I'm gonna leave it there,
Alright.
and I'll ask him. And be like, hey, how much of chapter 7, or if any chapter 7? But you may expect. I don't know if you may expect to find the electric field intensity based on a electric field intensity given, because you already had that on your homeworks. So from there, because the second half of it, even the K is you barely covered it. Yeah, it's in your book. Well, you do some manipulation to get your K. Yeah. But yeah. You want your chapter 4 homeworks? Homework 4 homework. I graded it today.
Yeah, which one's the least? Which science elective is the least math? Is the least math?
Yeah, for math. Math models go to number theory, Greek math.
Oh yeah, the geology one. Do you know which geology it is?
Oh,
That one? I don't think you can take it out. You used to be able to get tickets, but you can't
But
get one.
they specifically said it has to be like
Only usually sends out like an email, and then she has like a list of like what I can take one can.
it's only changing for you guys read that. I know for a fact that's on
So for the test 2 that's in Canvas, is the second problem, is that
No.
also,
That's chapter 4-5.
that's chapter 4?
Yes.
Okay.
That one, yes.
Okay, I don't even know what's in chapter 4 and 5, so
That's good.
I'm so
In math,
worried about
homework was like 40%.
Yeah, math models.
Can we get like the answers from him?
It's easy.
Oh, we finished on time though. I thought it was Russian.
Yeah,
are you able to give us the answers to those tests so we can check our work and correct it?
Yeah.
For this one, the one we did, chapter 3, the one I went over with you was the first question from exam 2, and then question 2 from exam 3.
Okay, wait, are the solutions on Canvas? Like,
No.
do you know them? Like,
I don't know them.
okay,
I would need to solve for them.
I see.
The only solutions I gave were the ones I had correct.
Okay, so
Review it.
we'll just, when we practice.
I got good equations. That's all you need.
The grade's like really easy for me.
That's good though. There was paper in this one. There was paper in here.
There's only like 6 people in our class.
I might take them in the fall.